Distributive property without coefficients. First, let me explain what I mean by without coefficients. If you look up here to the right-hand corner, you're going to see that I have another distributive property problem where the variable that's inside has a number in front of it. That number in front of it, that 4, is called a coefficient. For today's examples, we are not going to be looking at examples that have a number in front of a variable. In fact, we're going to keep it very simple. This first problem we're going to look at doesn't even have a variable at all, let alone a coefficient. And the second example we have does have a variable, but notice there is no number in front of it, meaning that it does not have a coefficient once again. So we'll put that x up here as well to show that we will do those in later videos, but right now we're going to try to keep it simple. So to go back to the first example, distributive property, what we're going to do is we're going to take this 2 that is outside of the set of parentheses, and we are going to distribute it to both of the terms that are inside the set of parentheses. Now the word distribute in mathematics means to give to both terms, and when I say give, what we're going to do is we're going to multiply, because anytime that there is a set of parentheses without a sign between it, that shows multiplication. But in this case, you're not only multiplying to the 3, but also to the other term, that -4. And I did say -4, because anytime you are distributing to a term inside a set of parentheses, you do have to keep whatever sign is in front of the number. So that 4 is actually negative. Now this 3 does not have a sign in front of it at all, which means that it stays positive. So when we distribute the 2 to the 3, that would become 2 times 3. When we distribute the 2 to the -4, that is going to be 2 times -4. And you might have noticed that I put a plus sign between the two of these, because when you're using the distributive property, you're actually finding the sum, or the addition between the two terms when you multiply them together. And that will keep things nice and clean for us as well, because 2 times 3 is 6. Now over here, 2 times -4 is actually -8. So to keep it clean, we'll put some parentheses around that. But to find our final answer, now we'll combine, or we'll add together, the 6 plus the -8, and that gives us a final solution of -2. Now, this particular distributive property problem was able to simplify to one term or one number, -2. This next example over here, this won't happen. You will not be able to get one number at the end like we did on the first example, because there is a variable involved in this one. That variable is x. Now, the reason I know this ahead of time is when we try to simplify the like terms, like we did here at the last step, where we had both constants. We had the 6 and the -8. Neither one of them had a variable. Well, I know that when we distribute this this -3 to both x and to -2, that means that we're going to have a term that has an x in it, so I won't be able to simplify it down to one number. So let's go ahead and see what happens. We're going to have -3 times x. Now I don't really have to put parentheses there to show multiplication. I could just write it as a coefficient, just like that. You know what, for the first step, just to be consistent, I will. Then we're going to add that to the product of the other two, which is going to be -3 times, and once again, you keep the sign that's in front, so we're going to actually write down -2. Now we can multiply. -3 times x is -3x, plus -3 times -2 is +6. Now, because this -3 is an x term and the 6 is what's called a constant, meaning it does not have a variable, I cannot simplify this any further, and this is as simple, or as simplified as the answer can get. So -3 parentheses x minus 2, when you distribute it, becomes -3x plus 6.